By now, you have already learned several ways to take the integrals of various different functions. You can do trig functions, you can do basic exponential functions, but there are some functions that you just can't simply integrate with your current practices. Look at this function, for example. Now, you would have already had to learn u substitution in order to do this problem, or in order to be at the point where you are now. So if we were to look at this problem, our first guess would be to use u substitution. But that does not work for this problem, so let's see why that doesn't work. If we were to do u substitution, we would have to make u this term right here. That's how we've been doing it ever since we learned it. So if u equals 4 minus x squared, that means du has to equal negative 2x dx. But the problem here is the fact that the x here is on the bottom. And there's no way to get this x here on the bottom while substituting for the dx here. So, and since du can't be on the bottom, that poses the problem why we cannot use u substitution for this. But there is one way in which we can solve this problem, and that's called trig substitution. Since you've already learned how to integrate various trig functions like sine, cosine, secant, etc., you can transform this into problems with trig in it and then integrate it. So you might think that might be hard to do that, but it's very quite simple. The first thing you have to look at is you have to look at this term on top, or this radical, and determine whether this is of one of three forms, either arcsecant, arcsine, or arctangent. And you do this by looking whether it's the constant first minus the u term, or if it's a u term minus a constant, or if it's the u term plus the constant. Since this is of the form the constant minus the u term, this is of this form arcsine. Now there are several rules you have to know when doing this, of course, and they are written right here on the board over here. If it's the constant minus the x term, or it's of the form arcsine, you use the substitution let u or let x equal a sine theta. If it's of the form arctangent, you use the substitution let u or let x equal a tan theta. And if it's of the form arcsecant, you use the substitution let x equal or let u equal arcsecant theta. So knowing this, we take the fact that we know it's arcsine, so it's going to be a sine theta, a being this constant term, but this is squared, so this is really 2 squared. So our a is 2, so x equals 2 sine theta. So now that we know this, we're going to set up a relationship with a triangle. But first I have to get sine all by itself in order to do this, so I just divide by the 2. So sine theta equals x over 2. So to put this into a triangle, you just draw a right triangle, it doesn't matter how you draw it, and you call this arbitrary angle here, and then you put in the values for sine theta being x over 2, so opposite hypotenuse. And then you have to fill in this side right here, and you use this, and you find that side using the Pythagorean theorem, and that consequently becomes this term here on top, square root of 4 minus x squared. So now we have a triangle. But what we have to do now is, like in this problem where we had this term over the x and we couldn't integrate that, we're basically going to go right back to this form, but instead of putting it over the x, we're going to put it over this constant term. So we have to find the trig identity, or the trig function that relates this adjacent side here. You have to involve this term with the x in it. That's like that makes it arcsine, the constant minus the x term. And then you want to put it over the constant. You want to relate it to whatever constant term you have in this problem. So adjacent over hypotenuse is of the form cosine. So you rewrite this as being cosine theta equals square root of 4 minus x squared over 2. Now what we have to do is we have to get the square root of 4 minus x squared all by itself. And we do this by multiplying over 2. So now we have the square root of 4 minus x squared equals 2 cosine theta. So we're going to take that value right there and put it back into our original integral. So instead of this being on top, we have 2 cosine theta over x. Well, if we wrote x equals 2 sine theta here, we can just we switch that out for that right here. And there's one more thing we have to do, and we have to take care of this dx. And we find that just by simply taking the derivative of this x term here. And the derivative of sine is cosine, so dx becomes 2 cosine theta. So then, let me get this out of the way. Dx equals 2 cos theta. So we replace the dx with my 2 cos theta. And then here's our problem. Now we integrate this. Well, on top we have 2 cosine, so that's 4 cosine squared over 2 sine theta. I can get these 2's to cancel out. This puts a 2 on top. And I'm left with this. This is now something that we know how to integrate. So, there are several ways we can go about solving this, but the easiest way I see is to replace my cosine squared theta with a 1 minus sine squared. That being of the identity sine squared theta plus cosine squared theta equals 1. So I use that identity and I replace that into my cosine squared theta. So that's going to be 2 times 1 minus sine squared theta over sine theta. I distribute my 2. So the 2 to the 1 over sine theta puts me 2 over sine theta minus the 2 to the sine squared over sine makes it 2 sine. This is now in a form we can very easily integrate. This becomes 2 cosecant theta minus 2 sine theta. The integral of cosecant, for those of you who don't know, is a special log integral. That is the negative natural log, I have my 2 out in front though, of the absolute value of cosecant theta plus cotan theta. So that takes care of this first part. Then the sine theta is a very simple integral, and that is just negative cosine. So it's minus negative cosine or plus cosine. Now we're almost done here. We've taken the integral, but the problem is we have theta in here where we should have x's. But all we do is we take this trig function here, and this trig part here, and this trig part here, and use that triangle to put back in values for this function. So to get the final answer, I would simply copy this down. Now, cosecant theta, that's the inverse sine, so it's going to be hypotenuse over opposite. So hypotenuse over opposite, that's 2 over x. Plus, cotangent theta is adjacent over opposite, so it's this over that. So, root 4 minus x squared over x. And then cosine theta is simply this over that. So it's going to be plus 2 root 2, and then these cancel out, and I'm left with that. So I'll be left with just the root 4 minus x squared. Plus c, of course, this is an integral. And this is my final answer. Next up, Cory will be giving another example. That's going to be a bit more complicated, but it's not that hard to do.
Welcome back. We've got another problem here for you. This one's going to be a little bit different, a little bit trickier. We've got 9x squared instead of just a regular x squared. Not a big deal, because 9 equals 3 squared. Pretty simple. We're going to start off 3x equals 5 tangent of theta. That way, because we have 25 plus 9x squared, you guys remember way over here, we got a constant plus a x term squared. In this case, it's 3x squared. Alright, so we draw our triangle. We're going to throw a 5 on the bottom, put a 3x over here because it's tangent, opposite over hypotenuse. And we got our opposite over adjacent, not hypotenuse. Hypotenuse is going to be 25 plus 9x squared, just like we got on the bottom here. And we're gonna do a little substitution. Forgot that little part there, but make sure you get tangent by itself so you can actually fill out your triangle, otherwise it doesn't work. And we re-plug in our value here to get the constant on the bottom. We'll have to take the secant to get the constant over, the constant underneath the radical. So we got secant dx. Alright, so we saw the dx on the top though, so we're going to have to plug in for that. We have our derivative for dx right up here. It's a real simple integration. Derivative. X equals 5/3 tangent theta, dx equals 5/3 secant squared theta. If you guys remember the Pist rule, secant, tangent, just cover up whichever one you're doing the derivative of, and you got the, right there, secant squared. So we plug that in for dx, so we have 5/3 secant squared theta over 5 secant theta. And like we always want in calculus, random things start canceling out, so there goes the secant on the bottom. We can cancel out a 5 now. So we're just left with 3 secant theta. And that's really easy to integrate. So we have 3 ln of secant theta plus tangent theta plus c. That's just going to be one of the rules you need to memorize. It doesn't take too long. You should memorize it quickly though. It helps later on. So we have that, but we still have the thetas in here, so we just got to go back up to our triangle and plug in what secant of theta is. So it's going to be 3 ln of the square root 25 plus 9x squared over the adjacent side plus tangent, so 3x over 5, opposite over our adjacent, plus c. There you go. We're done with all